Okay, this is the Chemistry C1 higher paper from June 2013, and I'm going to take you through each of the exam questions, how to answer them correctly, along with the mark scheme here, so you can correct these at home and add in any corrections that you need to, and just generally practice the information for the exam. Right, so we'll start with question 1. Right, so first of all, you give a little bit of information at the top. So we're talking about aluminium. It has many uses and it has 13 electrons. First question says draw, so you're going to have to annotate the diagram, the electronic structure of an aluminium atom. Now, electronic structure is describing how the electrons fit on the shell. If you've forgotten, we're basically talking about 2 on the first shell, then 8, and so on and so forth. And remember, you can only fill them from the inside out, so start with the inside first. Because you've got 13, you've got to place those on the shell, so begin with 2 on the first shell, and that is then full, then 8. If you pair them together, it's easier to count in the exam, and then you've got 3 remaining, which you can just put on the outside and count the 3. It's worth just double checking in case you're missing a cross, because you'll lose that 1 mark, and that is only 1 mark for that one. Okay, second question here says, name the 2 subatomic particles in the nucleus of an aluminium atom. And obviously the key bit is to name and 2 subatomic particles. Now, subatomic means smaller than the atom. So it's 2 things that are smaller than the atom, and they are found in the nucleus, so that's in the centre of the atom. Now, these things we've drawn on here are electrons, but it's asking for what's actually in the centre of the nucleus there. And the things we find inside the centre of the nucleus, the only other 2 subatomic particles there are is the the proton and the neutron. And you have to have both of those for the 1 mark. Right, part 3. It says there is no overall electrical charge on an aluminium atom. They are neutral. Okay, so again, really important is the word no. Overall electrical charge. Why is that? So we've got to explain, we've got to say why. And so if you look at an atom, and if you look at aluminium, we know it has 13 electrons. Now, electrons are negatively charged, so you've got 13 negatives from the electrons. Now, the other particle we have to know about is the proton. The proton has 13 positive charges because there's 13 protons in the nucleus of the aluminium atom. So if you look inside an aluminium atom, you will find 13 protons. Now, also, if we look at the formula for how it's arranged, aluminium has 13 at the bottom and 27 at the top. If you look at the periodic table, so that's where we get the 13 electrons from, and the 13 protons, and the difference is your neutrons, and it has obviously 14 neutrons. The problem here is that neutrons have no charge at all, so they are not important when you're looking at charges with the atom. So 13 minuses and 13 positives gives an overall 0 electrical charge. So for this answer here, basically what you need to have said is that the number of protons is equal to the number of electrons, and therefore there's no overall charge, or the charges cancel themselves out. Okay, so that's the first part of that paper. You turn over, it then gives you some information. It says rail tracks are made from steel. Molten iron is used to weld rail tracks. The reaction of aluminium with iron oxide is used to produce molten iron. You're going to balance the equation here for this reaction. Now, this is quite a bit of a helpful hint because it already puts some dotted lines. You can see here, I'll just highlight them again, at the front of aluminium on the left and the front of the iron on the right side of the equation. What that tells you is, if you see one of these questions, is that you need to then put a number here and a number here and nowhere else, because if you've got a balanced equation, the only places you can put numbers are at the very front of the formula. You can't start mucking about with the numbers here or start attaching numbers to the end of any of the different elements. Okay, so you can only really put them at the front, nowhere else. And it's telling you that you need to put them at the front of aluminium and iron to balance it. And so the easiest thing to do on this one is have a look on the right. Well, there's 2 aluminiums here on your right. So in order to balance that, you would need 2 in front of the aluminium on your left. Let's look at the iron now. Iron, obviously, we've only got 1 here, but on the left hand side we have a 2. That 2 there means there are 2 iron, and that's what you do there for the 2. And now it's balanced. And that's worth 1 mark because you have to have both of the 2's there to get both marks. B. Part 2. Why does aluminium react with iron oxide? And it's only worth a mark, and the reason is, of course, is aluminium is higher in the reactivity series. Okay, it's more reactive than iron, therefore react with it. So if I just draw a simple word equation here to help you understand. So aluminium is really quite high, it's quite highly reactive, and in that reactivity series it's quite high up. If you're going to react that with iron oxide, the aluminium is so much more reactive that what it will do is it will take the oxide off the iron, leaving you with aluminium oxide and iron. The iron is being displaced, and it's because aluminium is more reactive. Again, it's just simple revision from the metals unit in C1. That's the end of question 1. It was worth 5 marks, and the majority of that's factual, and you could have learnt that off by heart. It's just rote learning. Okay, question 2. This is describing metals now, so it's talking about metals are extracted from their ores. Many copper ores contain only 2% of copper compounds. Copper is now extracted from ores containing a very low percentage of copper compounds. Suggest 2 reasons. So again, with highlight a pen in my hand, what we need to focus on here? Well, first of all, we're talking about something with a really low percentage of copper in it, and we've really got to suggest 2 reasons, because here it's worth 2 marks. 2 reasons why the amount of copper that's extracted is from low percent copper compounds. Okay, now the reasons for that are quite many, so you only need 2 of them, but the main ones are, you know, copper is running out, so we really are down to the minimum amount of copper in the ores, and there are only there's a very small amount of high grade copper left. Copper metal is in demand, so there's not a lot of it left around. It's now expensive, the price has gone up, and to extract copper from its ore, from a low grade ore, is extremely expensive. Okay, so we have to find a way of doing that. And we have found some ways of doing that, such as phytomining, etc. But the main 2 reasons are going to be for this one, that the copper ores are running out, and it's in high demand, and what's left is going to push the price up a bit, so that's why it's more expensive. Okay, now I'll just pop that underneath the slide so you can see question 2, what we're looking at. So we've got reasons here. It's running out, there are no high grade ores left, the metal is in demand, and copper is expensive. Okay, you could talk about these new methods of extraction such as bioleaching and phytomining as well, if you wanted to. Then you get on to B. Right, now often you'll get these flow charts on your exam. It's really important to study them for a few minutes just to understand what's going on. They often will give you something that's not on the syllabus just to throw you off your path, but just follow the pathway of what happens to the material, and then you'll be able to spot certain key aspects as you go through it. So it's giving you the name of a copper ore here. It's got copper sulfide in it. Now we haven't come across that so much in the teaching, but copper sulfide should start to tell you that, oh, hang on a minute, what's this bit mean? It means it's got sulfur in it, so that should be something you should start thinking about. The flow chart shows how copper metal is extracted from this ore. So you can see here there's 2 methods. You can crush it, it goes into a separator, it's then going into a furnace, and then it's going through a process of electrolysis. The other side, you've got the lumps of the ore, and it's going through bioleacher or bioleaching process. It's then producing copper sulfate, and then follow it through, it still has to go through electrolysis at the end. So what does it say? So the first reason is, it's just suggest one reason why it's difficult to dispose of the waste rock. So why is it difficult to dispose of the waste rock? Right, now for this one, it is quite an easy one. And what you have to think about here is this fact that waste rock takes up an awful lot of space, and it's really hard to dispose of something that takes a large space up. So that's the main reason. So it takes up a large amount of space. 98% of the rock used for this is waste. Only 2% of it is actually useful. So there's the reason for this one. So it's just the fact that it takes up a lot of space would be the answer. Okay. Now I'm writing in shorthand here, just to give you the main key points, but again, they should be written in proper sentences. Part 2, the reaction in the furnace could cause environmental pollution. Explain how. Now it's worth 2 marks here. So you've got to talk about these key things. So you've got to find a reaction in the furnace, and you've got to talk about environmental pollution, and it's got to explain. If you see the word explain in the exam question, you've got to make sure you use the word because or therefore. So we're going back to the flow chart now, because we've got to look for a reaction in there that might cause environmental pollution. So we'll turn it back over. So if we look around the furnace here, separator, this is really important. I'm going to highlight the fact that we're using copper sulfide. You can see it going into the furnace, and you can see this waste gas being produced. So this is the area of focus for the answer to this question. You look really carefully at it. The copper sulfide is producing this waste gas here. Now the only waste gas you could probably see out of this would be something related to the sulfur perhaps. So perhaps the sulfur getting oxidized to sulfur dioxide, and the environmental pollution from that is acid rain. So there's one avenue you could take. Okay. The other one is the fact that you're burning up fuel, and burning up fuel which has carbon in it would make carbon dioxide, which obviously would cause global warming. So you could take both sort of steps from that. So the main one clearly is going to be related to the copper sulfide part of this. Okay, so we turn back this over. Explain how in the reaction you could cause environmental pollution from the furnace. And so your main objective is to explain that the sulfur would get oxidized to sulfur dioxide, and this causes acid rain. Okay, now I'll just pop the mark scheme underneath to see if there's any alternative answers for this one. Let's have a look. Okay, so yeah, exactly. So it produces sulfur dioxide, which causes acid rain. You could, if you have a look here, it says if no other mark is allowed, you could mention that carbon dioxide is produced, which causes global warming. But the main thing here is to focus on the sulfur dioxide. But carbon dioxide does cause global warming, but it isn't the main effect. Right. Question 2b. It then says the extraction of pure copper is expensive. Can you give a reason why? And there's again many acceptable reasons for this one. If we have a look at the mark scheme again for that, we've got reasons such as you will need a large amount of fuel for that furnace to get the heat up, and also to fuel electrolysis as well. You need large amounts of electricity for electrolysis. They've got many steps. Now this is quite a common response to this type of question, and they use it quite often. If you look at a process with lots of steps, each one of them may have labour costs of having to employ people, moving materials backwards and forwards, creating heat, adding catalysts, and all of those things might really push up the expense of that. Large amounts of ore material have to be mined, so there's an awful lot of mining that takes place, and again there's a cost involved with that, of employing people, running the machinery, etc. So if we look back at what the question is asking us here, why is it expensive? Any of them reasons would be a good one. The main one to focus on is probably the fact that it uses electrolysis, which is expensive, and the amount of fuel you need for the furnace. Okay, right, if I just move that up a bit. Right, copper is produced by electrolysis of copper sulfate solution. Which electrode do the copper ions move towards, and give your answer. Right, now then, if you mention electrolysis at all, it means that what you would have is a simple cell. This is part of C2, but you end up with a battery with a minus and a plus side. These then connect up to electrodes, which can be normally carbon, because carbon conducts, or it may be a metal. And what you would then do is, in this solution would be the copper ions that you're trying to extract. They'll be floating around. Now, if you have a look at your data sheet, on the reverse of that, you'll find out that all metals are positively charged. And there's a little simple saying I use, which is MIP. Metal ions are positive. You can also use this one as well. Metal ions always go to the cathode. Because what we do is, because the call the positive one the anode, the negative one is called the cathode, and because copper is positively charged, it will travel to the cathode, and it will then go through reduction reaction at the cathode. So in this case, we're looking for 2 marks. Which electrode do the copper ions move towards? Well, they move towards the cathode for 1 mark. Give you a reason: because they are positively charged. Alright, all metals are positive, all metals travel to cathode, so just remembering these little easy phrases to get you through the exam. Right, B, part 5. Large areas of land are contaminated with copper compounds. Phytomining can be used to remove these copper compounds from the land. What is used in phytomining to remove copper compounds from the land? Well, phytomining is a new sort of industry that's spread out to try and extract small amounts of metals from low-grade ores where there's hardly any metal in them. And it's the one where you grow the plants on them. So you grow the plants on top of the low-grade ore, they take the metals in through the roots and store them in the stems and leaves. And when they reach the maximum height, you then burn them, and in the ash you then have accumulated the metal. So the plant helps to accumulate the metals itself for you, and then you then cut those down and you put them through a furnace, and then you're able to extract them that way. So what's used to remove copper compounds from the land is just plants. Just one word here will get you the mark, and it's just plants. Alright, I'll just confirm that on the mark scheme. And there it tells you there, growing plants, and again it's worth 1 mark. That section's out of 9. Now the problem is, you see, there's 1 or 2 questions. If you hadn't remembered this, that would have caused you to lose a mark. Looking over what gases are produced through pollution, which is C1.5 as well, to go over that. Some of these are just common sense, so try your best under test conditions to try and think of a good reason why for those. Right, that's question end of question 2. Mostly metals, so if you get any of them wrong, look over your metals, reactivity of metals as well. Right, question 3. Right, this is crude oil, which is C1.3. If you get any of these wrong, look over that. Crude oil is a mixture of many different chemical compounds. Fuels such as petrol, gasoline, can be produced from crude oil. Fuels react with oxygen to release energy. Name the type of reaction that releases energy from a fuel. Right, dead easy this one, it's a combustion reaction. If anything burns, and you could even say a burning reaction, but you've got to name the type. So you'd have to go along with something that would express that, and it releases energy. And in that case, the answer for this could be, I'll just pop this underneath so you can see. You can accept combustion for this, burning, oxidation, or even those of you who've done C2, exothermic, gives out heat. Any of those would be acceptable for that answer. Right, it then says fuels react with oxygen to produce carbon dioxide, and the reaction of a fuel with oxygen can produce a different oxide of carbon. Name the different type of oxide of carbon and explain why it's produced. Right, so again you need the name of something. It's worth 2 marks, worth gathering a look over there. So you need the name, and it's a different oxide. So in this question, it's already mentioned carbon dioxide, so we won't be using that. It's a different type of oxide. There's only one other one, which is carbon monoxide, a deadly gas which is produced when there's a lack of oxygen. And obviously the best answer for this would be to describe it being incomplete or partially combusted. So the fuel doesn't fully burn properly, it only burns partially, and sadly that can produce carbon monoxide. Okay, so I'll just put the exam mark scheme underneath again. So if you look here, there's the name of the gas, carbon monoxide. It's incomplete, it's only partially combusted. You're not allowed to use carbon oxide, tempting as it seems, because you must use the word monoxide in order to get the answer. You could describe what incomplete means, which is that there is insufficient oxygen. Right, 3b. Right, where you have all this extra space here, use it. You may need it to explain what this diagram is showing you. Most of the compounds in crude oil are hydrocarbons. Hydrocarbons with the smallest molecules are very volatile. So already we're coming into something where really you need to know what a hydrocarbon is to really get all the marks for this, and volatile. So first of all, if you have a look at the word hydrocarbon, that means that you have a hydrogen or hydrogens and carbons in that particular compound. For example, I'll just show you the basic one, that's methane. So you've got hydrogens and carbons together. Volatile describes the way that some of these fuels turn to a gas very easily. It's not the same as flammable to do with how easily a fuel will burn or set on fire. Volatile is how easy it will vaporise or turn to a gas. And this is obviously fractional distillation that we're looking at here, because you can see crude oil coming in and you can see it's starting to split up. So before you even start the question, it is just worth looking at those, and maybe even just writing out what do you think these words mean. You don't know what these mean, it is just revision to learn the names of them. Right, now we get to a big 6-mark question. And again, in this question, you've got to use good English, organise information, use specialist terms. Describe and explain how petrol is separated from the mixture of hydrocarbons and crude oil. Use a diagram and your knowledge to answer this. Now you've got a lot of space there. Now obviously if we go back to this, now we know what the question is basically you put crude oil in here and at some point you're going to end up with petrol out here. How does that happen? Now it's worth annotating this diagram as much as you need to, and obviously you can put the paper out like this to help yourself answer this, because you could have the diagram there plus the writing to the side, and you can use both at the same time. Okay, so crude oil goes in at the bottom. The main things to mention about this is, I'm just going to write them next to them big and bold. Crude oil is a mixture, and it's a mixture of lots of different compounds, and anything that's a mixture is really easy to separate using heat. So already you probably gained a couple of marks by mentioning the fact that oil is a mixture and you can separate it using heat. So the crude oil enters the bottom of the fractionating tower, which will gain another extra mark by labelling and talking about this in the question. So this is the fractionating tower. And the crude oil goes in there at approximately 350 degrees, enters the fractionating tower. Then at this point here, all of the different compounds become vaporized. So all of the compounds then become vaporized, right, and turn to gas. And now as a vapor, they are now, I'm just going to show that by these little lines, they are travelling up the fractionating tower. Now all the way up here there are things called bubble caps, and as they approach the bubble cap, if that bubble cap there is their boiling point, they will then condense back down into a liquid. So from being gases travelling up the fraction tower, they then condense back down as a liquid. And then at that point you can separate them, and that's what petrol will do. So all I've done there is annotate all over the diagram what happens. So then what you would then do is try and think about logically how that would go in your head, and then how you would then write that down and have your double sheet over like that. So you just then describe, so you're talking about what happens to it, and explain, talking about what happens to its boiling point, how it vaporizes and condenses. You would then use those pieces of information to get the marks. You could plan that out on this page and just talk about the steps, trying to put them in order. It's going from being a mixture that goes in at 350 degrees, it vaporizes, it then enters the fractionating tower. At that point the gases travel up to the top because there's a vacuum pump at the top, and then they condense back down at their boiling point. We'll just have a little look at the mark scheme to get some ideas of what they were after for this. So these are some of the points, but again, if you're trying to get 6 marks for this, you need to do the following things. There's a reasonable explanation, how they're separated, using evaporating and condensing. You could use the word vaporizing is suitable also. And these are some of the phrases as well. So some or most of the hydrocarbon or petrol evaporate to form vapours or gases. When the fractions of the hydrocarbon cool to their boiling point, they condense. Hydrocarbons that have a low boiling point are collected near the top. Relatively high ones collect at the bottom. It's called fractional distillation, worth an easy mark. It's heated to 350. Some of the hydrocarbons remain as liquids near the bottom. Liquids float to the bottom. Vapours rise up the fractionating column. The cool as they rise up the fractionating column, and they condense and separate as they flow through the pipe. Some of the hydrocarbons can remain as vapours or gases near the top, and they do rise at the top of the column. The temperature gradient is cool at the top and hot at the bottom. So you need to really have picked 6 of those phrases out and try to explain how fractional distillation works to get the marks for that. Okay, right, and that's out of 9 marks. Again, most of that is just rote learning and learning the facts for that answer. Right, this is question 4 from Chemistry 2013, June paper, C1 higher. So I was up to question 4. I'm just going to run through this one with you. So first of all, have a look at the diagram that you're given for the question. It's mentioning some of the key aspects on here. So you've got a stainless steel ball part of the pen, a nickel alloy cone. So we've got 2 alloy metals at the bottom. You've got plastic all over it, so you've got the inner tube and the outer tube, and you've got a polypropylene cap and top. Now I know these are plastics because the word poly's in front of them, and that's how I know we've got 3 different plastics in these. So an advantage here of recycling materials from this pen, and one of the biggest ones is less waste would then enter the recycling. So you're going to reduce the landfill. That's one of the key bits. You're also going to conserve some of these materials, so you won't have to make them from new. So the likes of the metals, it's much easier to recycle them than have to mine them and extract them from their ores. And manufacturing plastics is expensive, so you reduce the cost of that. So reducing the landfill, reducing the amount of materials used, conserves resources. Any of them would be a really good advantage. The disadvantage has got to be that you've got a lot of materials on here, and all of these materials will need to be sorted before recycling. And also on top of that, some of them can't be recycled, sadly. So not all of the plastics, for example, in this case, could be recycled. And again, any of them would give you the answer. So I'll just once again pop the mark scheme underneath so you can see. So again, conserves resources, reduces landfill, uses less energy, and less carbon dioxide is produced in the process. Disadvantage is obviously you've got different plastics and alloys, and you've got difficulty in sorting them and a cost involved. And again, not all the materials can be recycled. Right. B. So I've just drawn a little sketch on this to explain what alloys are. Alloys are used to make the ballpoint pen. Give 2 reasons why alloys are used in a ballpoint pen. Right, the alloys are obviously here and here. And the reason is this. Now, alloys are a combination or a mixture of metals. When a metal is on its own, you can hit it and the rows will slide. If you inject another metal into that mixture, they often are different sizes compared to the others, and the lovely nice neat rows you've had above are now very unsettled. And this will disrupt the layers, and when you hit them they no longer move, and that makes them hard and it makes them quite strong. So you are getting strength with this and hardness, but not only that, if you're using stainless steel, you're also going to reduce the risk of corrosion. So if I just run through B with you as well. So hard, strong and durable, resistant to corrosion. Alright, or do not rust is the simpler answer for that one. Right, question 4C. Again, they do like these flowchart diagrams. It is worth your time just looking at them and seeing what you think is going on. So decane, C10H22, can be used to produce polyethylene. Now decane ends in ane, so what I know I'm dealing with here already is I'm dealing with an alkane. In the reaction, you can see there's two reactions, reaction 1, reaction 2. In the first one, if you look carefully, decane, you don't add anything to it, it's going straight into two products. So it's obviously being broken down into two products. Now when you're dealing with this process here, the only one that does that is going to be cracking. So this first reaction is cracking, which is the breaking down of a larger hydrocarbon into smaller ones, which are generally more useful. And one of the products is C8H18, that's octane, and this one, C2H4, is not an alkane, it's an alkene, because what you've done is just double the number of carbons. With this one, if you double the number of carbons, you would have 16, but you've added 2 more, and that's how I know that's an alkane. If you double that and add 2, that gets you 20, that's an alkane. If you only just double the number of carbons to work out your hydrogens, that's an alkene. So the first reaction is an alkene. Reaction 2 looks like lots of these combined together to make a polyethylene. So you're going from alkenes to polyethylene. So this process here is going to be polymerization. Just take the time to break it down, and you can also add words on to this to help you. So step 1 for 4C, describe the conditions needed for reaction 1. So describe means talk about what's happening or what do you need. The conditions though makes it more specific. So for the specific temperatures, things of like that you need for reaction 1, you've got to state them. Now for reaction 1, you've got to be quite careful with this one. First of all, you're going to need really a high temperature. So for cracking to occur, one of the key things you need is a high temperature. You also need a catalyst. Now that's either called, it's got two names, aluminium oxide. It's also called porous pot. So in order to convert decane into a smaller alkane, and then you get a bonus of a small alkane unit, you're going to need a high temperature and you're going to need a catalyst. Now this is worth 2 marks, and that's what the 2 marks are for, the high temperature and the catalyst. Now C part 2 asks you to describe again, but if you look carefully at the question, in terms of molecules, how polyethylene is produced. So what you've got to talk about here is how you actually get lots of these tiny little alkenes to make a massive long chain polymer. How are you going to change those to those? Now I've drawn these quite a lot in the lessons. I'll give it another go. If you remember, an alkene has a double bond in, and I've always taught this way. You have 3 of them. So you put 3 of them next to each other, and you're quite willing and happy to draw these on your paper. Obviously I've drawn them a little bit too big, but again, it just helps. So that's 3 of those little ethene units together. Each one of these are called a monomer. Now how do we join these up again? Right, well remember what you've got to do is take that bond there and pop it across here. Take that bond there, and again pop it across here. Take the bond off there and pop it across here. What you actually do is you open the double bond up, and so the double bond goes in between the different monomers and they're linked together. So it's opening the double bond to do that. So what you've got to say here is many monomers. I've only drawn 3, but the monomers join together, and there's your 2 marks. So you have to use the word monomer, and you have to say that they join up. And for that, you would get your 2 marks for that question. Again, it's revising what cracking is, it's what is polymerization, and it's remember what a monomer is and how they join together. It's talking about molecules, which is why I've drawn 3 of them. So in the question, if it asks you to talk about these things, draw one of them, because then you can express how that actually happens. Right, okay, now on the second page for this question. Right, question 4D to finish this off. It says complete the displayed structure of the product in this equation. This is a really hard question. And what you have to do is you've got a small monomer here called styrene, and you need to show what an equation would look like if you made polystyrene. Now the first thing you remember is the double bond has to go. So what you do is you get rid of the double bond. You'd still have on your H's because you're making a specific plastic, so still put the H's on there. Now this is just a little side group, so don't worry about it, it just remains. Alright, and then what you then need to do is start adding in your brackets. Now they go around the whole structure like so, and then this is the bit that shows it's a polymer, and these are the side arms to show that this is where the monomers join together. That would join to a monomer, that would join a monomer, and what you've made there is a polymer. Now the marks for this show the following things. You've got to have these lines extending, there's 1 mark. You need 7 single bonds, and they're used in the correct place. Okay, and the brackets are in the correct place, and of course you need the N at the end. Okay, it's worth just having to check that you've got 7. 1, 2, 3, 4, 5, 6, 7, N at the end. N stands for the number of monomers in that chain that are then together. That stands for the number of monomers you have at the start. It's worth 2 marks, so remember that is for the lines going outside the brackets and for the 7 bonds drawn in the centre. Notice there's no double bond, because when you joined 3 of these or more together, that bond there, I'll just draw on this one, that bond on the top would then pass on to the next, etc., as in the last question. It's worth 10 marks. Okay, so no double bonds. Put your brackets around. Extend the central carbon links over the arrows, over the brackets, sorry, because that's just showing that it links together multiple times. Alright, now that finishes question 4. Okay, so now moving on to question 5. Right, so this says the amount of carbon dioxide in the Earth's atmosphere has changed since the Earth was formed. The amount of carbon dioxide continues to change because of human activities. Cement is produced when a mixture of calcium carbonate and clay are heated in a rotary kiln. The fuel mixture is hydrocarbon and air. Hydrocarbons react with oxygen to make carbon dioxide. Calcium carbonate decomposes to produce carbon dioxide. Complete each chemical equation by writing the formula of the other products. Right, so if you look at this statement here, it's telling you a little bit about what's produced. So you've got hydrocarbons react with oxygen to produce carbon dioxide, and also that calcium carbonate decomposes to produce carbon dioxide. But when a fuel burns, and that's methane, so when a fuel burns with oxygen, you get 2 gases. One obviously is carbon dioxide, the other is water vapour, and again you can learn this equation off by heart, and the formula for water is H2O. That's worth a mark, and the thing is this is already balanced, which is brilliant. When calcium carbonate breaks down, you're left with CO2, but if you took CO2 from calcium carbonate, just removed it, take CO2 from that, you would see you'd have calcium left you'd have no carbon because you removed it, and you can take 2 oxygens off that, so you'd left with CaO, which is calcium oxide. But if you'd looked at taking CO2 off that formula, you would have been left with that. Right, this next question causes a lot of problems. Hydrocarbons and calcium carbonate contain locked up carbon dioxide. What is locked up carbon dioxide? What that means is that the carbon dioxide in the Earth's early atmosphere was then combined with other elements and combined with rocks, etc., and then formed part of these compounds or rocks. So carbon dioxide from the air's early atmosphere formed in rocks or fossil fuels. Okay, it's worth 2 marks. You need to have said carbon dioxide from the Earth's early atmosphere, and that it formed rocks or fossil fuels. So that's how the CO2 has been used up in some of these particular compounds. Fossil fuels, because the methane comes from crude oil, and calcium carbonate is a very old sedimentary rock, and that's where they've come from. Okay, so just pull that mark scheme up so you can just double check what I've said there. So carbon dioxide from the Earth's early atmosphere, and it's formed sedimentary rocks or fossil fuels. Question 5b. So you've got a graph here. It shows how the percent of carbon dioxide in the atmosphere has changed in the last 4,500 million years. And if you look at the graph, you can see what's happened. It's around 80%. Look, about 4,500 million years ago, there's quite a steep decline till about 3,000. It starts to level off a little bit, still decreasing, mind, all the way through to present day, and it's down to 0.03. It's a massive decline, a very steep decline, and then a constant decline over from 3,000 to present. Now, what question 5bi says is the word describe again, which means you're going to have to talk about what's happening. How the percentage has changed in the last 4,500 million years. Well, there's clearly, and it's worth 2 marks, there's clearly 2 areas to look at, isn't there? There are 2 parts to this. Okay, now what we have to say is for the first one, as it decreases very rapidly at first, you can see there's a very quite steep decrease here, and then it starts to level off, and that's all you have to say for this mark. So without any signs whatsoever, you've just got to describe the graph. So at the start you need to say it decreases very rapidly, and then it slows or levels off. And that'll get you the 2 marks. Right, B. Give 2 reasons why the percentage of carbon dioxide has changed. There's quite a few reasons, but because you're going right back to the start of the Earth's atmosphere, what you have to remember is that the plants took in an awful lot of carbon dioxide when they evolved. That made the percentage drop quite a lot. Quite a lot of it dissolves in the oceans, and it can become locked up in fossil fuels. I'll just show you the mark scheme for that one. Except photosynthesis occurred, but you really do need to mention the fact that plants dissolved in oceans, gets locked up in fossil fuels, or locked up in rocks, sedimentary rocks. Okay, right, now question 5 continues over the page. Again, this is quite a tricky question. Graph 2 shows how the percentage of carbon dioxide in the atmosphere changed in the last 250 years. So you've got time in years ago, the percentage of carbon dioxide. Now this is different from the previous graph because this is not going back to 4,500 million years ago, it's just the last 250. So it's a smaller time frame first off. If you look at the scale on the y-axis, it's going up in very small amounts, 0.01. It's very, very, very small amounts. And bear that in mind when we look at the question. Should we be concerned about the change in the percentage of carbon dioxide? Explain your answer. There are 2 ways you can write the answer to this. One of them is yes, you should be concerned, and one of them is no. Because you've got to use I've got the command word here, it's saying explain. You're going to have to say why. So you need to use the word because, or therefore to actually explain your answer. Okay, right, if you're going to go along the lines of yes, we need to be worried about this, because any increase in carbon dioxide is causing global warming, or causing global warming to increase. You can express the opinion of that. If you go along the regions of no, you could look at the fact that it hasn't changed that much. You're talking 0.01%, which is really quite minimal compared to where it was millions of years ago, where it was up to 80% of the atmosphere. So you can go with either option, and again I'll just pop the mark scheme underneath so you can just check what you've done. So yes, because it's increasing, which can lead to global warming, or no, because it's low, and again, really, can that have that much effect on the environment? And it's come down an awful lot to where it was millions of years ago. Alright, and also there's another valid point mentioned in the mark scheme. Other things can affect global warming, such as the amount of water vapour and methane gases as well in the atmosphere. Right, so that concludes question 5. It's worth 10 marks. Be aware on this one, there's quite a lot of data analysis on that as well. Those two graphs to study, and that's just you analysing graphs. If you're really losing all the marks on there, you need to get some extra help with just looking at data and what the data means, or in the exam, sit and focus and actually look at what the information is telling you. Right, this is question 6. Okay, so the background reading is there were many ideas about how the Earth was formed from a molten ball of rock and minerals. At one time, scientists thought the features of the Earth were caused when the molten ball of rock and minerals cooled and wrinkled. So there's a little sketch of the Earth and how it then formed these crusts, and this is how the mountains are meant to be formed that we have in the Himalayas, etc. Scientists now have evidence that the Earth has a layered structure. Describe the layered structure of the Earth, indicate the relative sizes of the layers. It's worth 3 marks. Now again, you should think about maybe a diagram that might help. So if you draw, which is effectively what a boiled egg would look like, so you've got the outer crust, the shell, then you've got the yolk in the middle, and then you've got the egg white, which would be the other part of the Earth. So the outside of the Earth is called the crust, which is the thinnest part. You then get into the mantle, and then you get inside, which is the core, and all made out of different materials. The crust is made out of rock. It can go underneath the seabed. It can be very thick, it can be kilometres thick, and it can be quite thin. And obviously that's where you get breaks in the crust and you get volcanoes formed. The mantle is underneath the crust, which is molten rock. The core has an inner and an outer core. The outer is first, the inner is in the centre. So the outer core is liquid iron nickel, the inner is solid iron nickel, and the difference there is the pressure force and the particles close together, so that's why the internal one is solid. So if we go back to the question again, here's that describe word again. Describe the layered structure. Well, I've got a diagram which does partially answer the question, and the relative sizes of the layers. Right, so what's acceptable here? So you should first say that there's the 3 main areas: the crust, mantle and the core. The positions of them, that the crust is the outside, then the mantle, and then the core, which is your 2nd mark. And for the 3rd mark, what you should have said is the crust is thinner than the other 2. And it said they would accept a correct label diagram for this, and don't be shy for doing one. And if you've run out of time, a quick sketch might get you the marks. If you've got time, go back and then fill it in, but if you are struggling for time, sketch it out first, because that will give you 1, possibly 2 marks, that diagram there, if you can show the variation in the thicknesses as well. Right, question 6b. One time scientists thought the Earth's continents were formed in fixed positions when a molten ball of rock and minerals cooled and then wrinkled, which is above. In 1912, Alfred Wegener suggested his idea about how the Earth's continents formed. You've got to describe Wegener's idea of how the Earth's continents formed. So this word's cropped up a lot, so the command word is described. You're going to have to go through his ideas and what he thought, the process. Okay? And the scientist we're looking at is Wegener. Right, so for this reason we have to think about what Wegener's idea was. And he suggested his idea how the Earth's formed, and it was that the Earth at one point, if I draw a quick sketch of planet Earth, is that all of the little different landmasses were actually one giant landmass, and that was called Pangaea. and that all the different land masses then split apart. Okay, so draw that sketch again, and you get all of the different continents. Badly drawn, I know. And now that process there is called continental drift. Okay, so what were the two main points for here? Describe the idea of the Earth's continents were formed. We need to go back to the start to describe them. So there were one massive supercontinent called Pangaea, and that then the continents then drifted apart, or moved apart for 2 marks. So what they were originally, what they are now, and that it's called continental drift. Now what drives that though isn't part of the question, but it's worth remembering. What drives that process is that deep within the Earth's mantle core, radioactive sources decaying, generating energy. No, the massive amounts of energy create convection currents in the mantle, which create these diagrams here, and create these currents within the mantle of heat, and they either move the plates apart, or if the currents are going the opposite direction, move them together, and that's what drives the plates apart altogether. Okay, and that's called plate tectonics, and that was by another scientist called Holmes, who developed that idea in the 1950s, and that's the difference with that. Again, 2 marks there. You don't have to mention about the the convection currents, but you do need to mention that part, how they're split. And that's worth 5 marks, so that's into question 6. Right, this is question 7. So this one is about research into fuels for car engines. You've got a list of fuels here. You've got what the main components are, the melting point, the flash point, and how much energy they released. It's worth knowing what the flash point is: the lowest temperature fuel vapor will ignite. Okay, and that's worth knowing what that is too. The melting point of ethanol is precise, but other melting points are approximate. Suggest why. Well, if you have a look, it's quite easy to see that ethanol is a specific compound. You can see its structure there. This is giving a vague idea of them being hydrocarbons, and fats. So what's saying is the rest are mixtures. So for 2 marks here, we have to say why the melting points are only approximate. Well, the reason is, for these 3, they're a mixture still of compounds of similar sizes, but they're still a mixture. Whereas this one here is the actual compound itself. And when something as specific as that, it will have its own specific boiling point and melting point. But these ones, unfortunately, are a mixture here, so you'll get a variation or an approximation of the melting, boiling point, etc. Alright, so let's pop the mark scheme on to show you the marks for that. So it's only made up of one type of molecule, whereas the others are mixtures. Okay, again, 1 mark for that each. Next question. Ethanol is produced by fermentation of sugar. Okay, and that's really important. So obviously you've got a name of something, highlight that. Rapeseed oil is produced by pressing. Waste plant material from both processes can go on to feed animals in farming. Here's that word again. We've got to describe this time. Describe how the process of fermentation is done. Now this comes into the biology units as well, so it's worth remembering what fermentation means. Because fermentation is where sugar is put together with yeast and warm water, and in that process there, what you will get is you'll get some ethanol, you'll get some alcohol produced, and you'll get some carbon dioxide. And that's how we make alcohol. Now, how is it done? Well, this is before the arrow. Not what we make, it's how is it done. So you're going to need some sugar in here, you're going to need some yeast, and you're going to need some warm water. And this creates the right sort of chemical reaction to take place for fermentation. And it's important, it mustn't be too hot. It's got to be about 40 degrees, 35 to 40 degrees. Too hot, it actually kills the yeast because they are a microorganism. So let's put mark scheme back underneath again. So for this question, sugar is mixed or dissolved with water, yeast is added. Again, really easy, factual information, something you could have revised and just remembered for that one. Okay. Right, to 7b part 2. Carbon neutral fuels do not increase the amount of carbon dioxide in the atmosphere. We've got to suggest now, so we've got kind of like give a reason. So suggest means give a reason why a biofuel, such as ethanol or rapeseed oil, is thought to be carbon neutral. Well, the first thing you need to remember is all of these are produced from plants. Right, and as a plant grows, it will take in CO2 from the air in order for photosynthesis to take place so it can grow. Then, as it's then converted to a fuel, and it's then burnt in an engine, it will give out CO2. And then what you could do is almost complete the cycle of it going around in this direction. So the plant takes in carbon dioxide for photosynthesis. It then becomes part of a fuel, a biofuel, bioethanol, or just pressed into rapeseed oil. It then goes in an engine, and as the fuel is burnt, it makes carbon dioxide, and this is why we get up with this whole new, and this is quite a common question about carbon neutral fuels. Okay, now I've got to say now why these things are carbon neutral. So you need to start talking about the story of it, so that the plants take in carbon dioxide for photosynthesis. They then convert to a fuel, and then in the burning process or the combustion of the engine they give out carbon dioxide. So what they take in they then give out, so overall the impact on the environment is minimal. Okay, now it might be worth you having a little look at this here. So what it says here is growing the sugar cane absorbs carbon dioxide which is released when it's burnt. Okay, you've got to be careful what you choose here and the words that you use as well. It is interested in photosynthesis as well, you can use that. Okay. Yeah, so that's what you remember for that one. Alright, last question of the paper. No, I've got 2 left. Right, question 7. When any fuel from the table is used in a car engine, the exhaust gases contain nitrogen oxides. Again, it's worth 2 marks. Explain why. Right, well, it's going back to what the air is made up of. I'll just pull the paper down. So if we go and look at a pie chart of what's in the air, so 78% of the air is actually nitrogen. Now, and then roughly, and that's a very rough diagram, 21% is oxygen, and then you have 1% of other gases roughly as well. So if most of the air is nitrogen and oxygen, no wonder you're going to get nitrogen oxides produced. So what you have to remember for this is in the car engine, nitrogen and oxygen are pushed together through pressure and high temperature, and that's how you make the nitrogen oxides. And the mark scheme for this is basically for you to express that both of these things are in the air for 1 mark, and that in the engine where it's hot, these 2 gases then form a compound called nitrogen oxide. And that gets you the marks again. Just show you the mark scheme for this one. The nitrogen and the oxygen in the air react with the hot engine at high temperatures, and there are the marks for this one. Fuels don't contain nitrogen. Right, the last question. Okay, it says, evaluate replacing petrol with ethanol as fuel for cars. To gain full marks, you should use a justified conclusion. Use information from the table and your knowledge to answer this question. First of all, you've got the word evaluate, which you need to look at. You need to give a justified conclusion. You need to use information from the table and your own knowledge. And so for this point here, we need to remember what evaluate means. So that means looking at advantages and disadvantages in order to get full marks, which is what we're going for. Or in simple terms, pros and cons. You've got to then give your opinion, a justified conclusion based on data or evidence, and then try and get this in there. Now it's worth 4 marks. So you would really, to be honest, worth spending your time just writing pros and cons for replacing petrol with ethanol. Okay, right, so let's go through them. So what we have to look at here is some of the reasons. So ethanol really does need a higher temperature to burn. It has a higher flash point than petrol, okay, and that's going to be an issue. So you need a higher temperature to burn the petrol, which you can get that from data from the table. Okay, so if you look here, the flash point here is a lot higher than it is for petrol. So there's one reason we can go for. Ethanol releases less energy than petrol. Okay, so there's our major cons here. So you need a higher temperature, and it releases less energy. It's only worth 4 marks, so 2 of each would be decent. The pros for this, using ethanol. Ethanol is sugar. Sugar is from a plant, so it's going to be renewable. Could also talk about sugarcane not being very reliable. Sometimes the sugarcane plant can suffer from drought or from insects attacking it from wherever it's from, and the crop can fail. So you could put that in your cons as well, but I think we've got the main two. You could also talk about the fact that this is it's a much cheaper process as well. It's a cheaper process to make ethanol, so it's much cheaper and it's easier to make. Is a pro for using ethanol. Okay, it is also quite a slow process. You'll also talk about being carbon neutral as well. So once you've done that and you've sort of divided your page up, you then write out it in full detail. And obviously you're trying to go for full marks. It's important that after you've put your paragraph for ethanol, your paragraph against ethanol, that you come up with your own conclusion. Another really important reason from the list why you should replace petrol with ethanol, or perhaps save the most important one last. Perhaps go for the carbon neutral as a really justified reason for doing so. Okay, so you basically, if I just pull this out in front so you can see, these are some of the reasons you could give. Ethanol needs a higher temperature. Ethanol releases less energy. Okay, and a good reason, sugar is renewable, but sugarcane is unreliable, the growth of it. Ethanol is made by batch, so it can take a bit longer to make. Ethanol production is carbon neutral. Another reason is sugarcane could be grown for fuel instead of crops, and in a poorer country that would lead to food shortages. Okay, and so all you would do then is give a paragraph for your pros, a paragraph for your cons, and then a justified conclusion at the end. Alright, that's the end of the paper. That last question was worth 12. Now I would go back and just look at the topics you've done weakest in, with the number of marks at the end of each question, and revise those in detail. Go back and look at your paper about the ones you've got wrong. Have you really looked at and highlighted the key ideas? Did you know what to do for evaluate, for example? The majority of this paper though is reliant on revision, and that you've picked up the key ideas from your revision guides, etc., your book, and the revision material provided in order to get as many marks as possible. Okay, so that paper wasn't too bad. Right, thank you.